Hello everyone. Today we will discuss about the formation of PN junction. PN junction is the building block of most electronic devices, that is transistors, diodes, etc. So that's why we need to understand what is PN junction and how it is formed. So for formation of PN junction, a small wafer of P-type semiconductor is taken, and then in this small wafer, in one part, the pentavalent impurity is added in very small amount to make that part. So you can say that P-type wafer is taken, and then small amount of impurity is added to some part which is pentavalent impurity. Right, and then so this way now the wafer which is here is having P-type characteristics on one side and N-type characteristics on the other side. So this is the P side and this is the N side. We know that on P side the majority carriers are holes and on N side the majority carriers are electrons. And on P side, when holes are majority carriers, here electrons are majority. So what happens is that these holes diffuse from P to N side, and here electrons are majority, so electrons diffuse from N to P side. So this is diffusion. You have studied diffusion in bio or chemistry also along with physics. What is diffusion? Diffusion is the shifting from higher concentration side to lower concentration side. So this is diffusion, this is also diffusion. So what happens is that these holes, when these holes are moving from here to here, these are leaving a negative ion behind it. So you can say that here we have studied this while discussing p-type semiconductors. So here this is the case, and when it is moving here, the holes are diffusing this side and ions are left behind. And these negatively charged ions, these will remain in the crystal at their place. So these ions are immobile. So you can say this negatively charged core are left behind here, and in this case this is the positive charge and the electron, positive and electron, here also positive, and electron is moving this way. Similarly, I can complete the diagram over here. So what happens after some time? After some time, there is an accumulation of the negative charges on p side and the positive charges on n side of the junction. Why? Because these holes are diffusing this side and these holes and electrons are recombining. So what is happening after some time? Here we have negative, here we have positive. So these are accumulated near the junction and the holes and the electrons recombine while crossing the junction. Therefore, we can say that this layer, which is formed due to the diffusion of holes from p side to n side and electrons from n side to p side, this layer is formed where there are no free electrons or holes, or you can say that this layer is called as depletion layer because it is devoid of free charge carriers. Right? So this is happening after some time. Right? Then what happens? Due to the accumulation of these ions over here, an electric field is developed, and this electric field is developed like this. So what is the direction of the electric field here? From positive to negative. So I can say that what the direction of the electric field here is this way. There is no place over here, that's why I am marking it here. Now what will this electric field do? We know that under the action of electric field, the positive charges move towards the direction of electric field and the negative charges move opposite to the direction of electric field. In this case, we know that on n side, we have electrons as majority carriers, but there are holes also, right? So now the holes on this side will start moving under the effect of this electric field which is developed, and electrons which are minority carriers on p side will start moving opposite to this developed electric field. So what is actually happening is that the minority carriers on both sides start moving under the effect of the developed electric field. So I can say that here electrons are majority, holes are minority, here holes are majority and electrons are minority, right? So what is happening, that electrons move from P to N and holes move from N to P under the effect of the developed electric field. So I can write in short over here that the minority carriers start moving under the effect of the developed electric field. This process is called drift. This process is called drift, right? So this results in drift current. While what was happening here? Here diffusion of holes from P to N was occurring and electrons from N to P was occurring, and this was diffusion. So diffusion results in diffusion current. So diffusion is occurring for the majority carriers and drift is occurring for the minority carriers. Diffusion is occurring due to concentration difference across P and N side, and drift is occurring due to the electric field developed due to the accumulation of the ions across the junction, right? So this is the difference between diffusion and the drift. Now the question is asked in the boards, which two processes are responsible for the formation of PN junction? So the answer in short is, I have drawn so many diagrams here just to explain what is happening actually, right? So in short, we can mention it that the processes responsible for the formation of PN junction are diffusion and drift. So in this, we can sum up the difference in short. So this occurs movement of majority carriers occurs. Here movement of minority carriers occurs. Second is, this is due to concentration difference across P and N side. And this is under the effect of the electric field developed due to the accumulation of the ions across the junctions. These are the two major differences here. And we can mention third thing also, this results in diffusion current, this results in drift current. So this results diffusion current and this results drift current. We can draw the overall diagram for showing the processes of diffusion and drift. We can draw the diagram. So there is an accumulation of charges around this junction. So here there will be accumulation of negative and here on the other side positive charges will be accumulated. Okay, and this is the depletion layer, right? And we know that the diffusion of majority carriers takes place. So this is the P side, this is the N side. Here majority are holes. So you can say that holes diffuse, okay, from P to N, right? Similarly, electrons diffuse from N to P. Because here electrons are the majority carriers, and then drifting of minority carriers occurs. So here what are minority carriers? Holes, and here electrons are minority carriers. So you can say that electrons drift from P to N, and here holes drift from N to P, as holes are minority here and electrons are majority here. This we have already mentioned. Now we need to write the definition of barrier potential. So across this depletion layer, so we talk about this, this is the depletion layer, and here so this potential difference which is developed due to the development of this electric field due to the accumulation of the ions, or you can say the charges across this junction, this stops the further flow of majority carriers. So that's why this potential difference developed is called as potential barrier. This is the potential difference developed across the junction across the PN junction due to the accumulation of the charges across it, which prevents further flow of free charges across the junction, or you can say which prevents the further flow of majority carriers across the junction. Because this supports minority carriers, but majority carriers this opposes it, right? So this is all about your barrier potential, diffusion and drift. So we know that this electric field developed due to the accumulation of the charges or ions, it opposes the further flow of majority carriers, but it supports the minority carriers. That means it results in drift due to the development of the electric field due to the accumulation of these ions or charges. So that's all for now. Have a nice day.